So now the difference between the crystalline solid and amorphous solid. Here are the properties we are going to differentiate between the crystalline and amorphous solids. So one by one I am going to take. The first is shape. So the shape, crystalline solids have regular pattern and that have the definite geometrical shape. So it has the definite geometrical shape. But in case of amorphous solids, they doesn't have the definite geometrical shape. Not have definite geometrical shape. So here, now the next property is physical property. So actually crystalline solids, the intermolecular particles, interparticle forces are very strong. So they have very strong forces in between the particles and they are elastic and they are very hard. Have strong interparticle forces and elastic. But in case of this, less force of attraction comparison to crystalline solids, right? Then crystalline solids and are soft, right? Now the next is the symmetry. The crystalline solids are made up of regular pattern arrangement particles. They possess symmetry, but in case of amorphous, they doesn't possess the symmetry. They are not symmetrical. These are symmetrical. Possess symmetry and they don't have symmetry. Right? Now the next is interfacial angles. Interfacial angles, if you don't know what is interfacial angles, the planes, the angle between the planes are called interfacial angles, and ahead we are going to talk much more about it, right? Now here is the interfacial angles, because the crystalline solids are made up of regular arrangement of the particles, so they have definite planes, definite geometry, so they have interfacial angles. But in case of amorphous solids, they doesn't possess any kind of interfacial angles. Not present. Right? Now the next is melting point. The melting point is because the crystalline solids have the regular arrangement of the particles, so they have a sharp melting point. Whether in case of amorphous solids, because they don't have the regular arrangement of patterns, they have irregularly arrangement of patterns. That's why they have over a range of boiling point and melting points. Over a range means, for example, 50 to 56, whether it may be 51, 52, 53, 54, right? So over a range. Sometimes it is 51, sometimes it is 50, sometimes it is 50.5. So depths. So over a range. Amorphous over a range, and here crystalline solid, it has a sharp melting and boiling points. Has sharp melting points, where in case of amorphous, over a range. Right? Now the next is order of arrangement of particles. So long range order, because regularly arrangement of atoms present in the crystalline solids, so long range of order is there. while in case of amorphous solids, there is neither kind of regular arrangement of pattern, so one or two particles may be arranged in the line, but they are irregularly arranged. That's why short range order. So here long range order, while in case of amorphous it is short range order. Now the next property is cleavage property. So cleavage property is to break into the pieces. So when the crystalline solids break into the pieces, it gives the pieces with smooth surfaces, right? So they split into pieces with smooth surfaces. While in case of amorphous solids, because irregularly arrangement of pattern is there, so they split into pieces with rough edges. Now the next is anisotropy. So actually, what is anisotropy? After this difference, we are going to move on the anisotropy. What is anisotropy? We will discuss about that, right? So here, anisotropy, actually crystalline solids are anisotropic and amorphous are anisotropic. So after this difference, we are going to talk much more about the anisotropy. So anisotropic, while it is isotropic. Now the nature. The nature is they are true solids. The crystalline solids are true solids because they have regular arrangement of the atoms. Now the crystalline amorphous solids are not true solids. The amorphous solids are not true solids. They are pseudo-solids, or sometimes they are called supercooled liquids. Pseudo-solids or supercooled liquids. So now for example, here is some example, like for example it is NaCl and other CaCl2 crystalline solids, right? etc. Now here the amorphous solids, for example glass, rubber, etc. So here are the differences between the crystalline and amorphous solids, right? I hope that you come to know about the crystalline and amorphous differences. Now come to the point anisotropy. This is the point. Anisotropy. The crystalline solid is anisotropic and the amorphous is isotropic. Why it is so and what is the anisotropic phenomena, right? Now next move to that. So here we are going to study about the anisotropic property. What is anisotropy means, right? So here we have studied so far that the crystalline structures, crystalline solids are anisotropic in nature and amorphous solids are isotropic in nature. So let us see what is anisotropy means. So the anisotropy means is actually when some physical quantity measured along the different directions of the crystalline structure, then different values of the physical property comes. So this phenomena is called the anisotropy, right? and let us see how and why this anisotropy come in existence in the crystalline solid, right? So here